Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is unequal arrays and it is a medium level problem. So I believe that this problem is of medium level because of the way you have to implement this. It has small implementation details. Other than that, I believe it contains no such thing that would to be of higher level. The main idea is very simple. It's just that you have to implement it in a way such that it passes all test cases, right? So let us discuss the problem now. It says that we have been given two arrays of a and b of each length n, right? And we can perform the operation on the array a 0 or more times. Now what we have to do is we have to select any two indices and set one of them like a of I as a of I plus 2 and set the other of them a of j as a of j minus 2, right? Now we have to find the minimum number of operations to make a and b equal. Now they have also given the definition of what they mean by equal. They say that two arrays are said to be equal if the frequency of each element is equal in both of the arrays, right? So this is the whole problem. Now let us discuss the problem with a small sample test case. So this is the sample test case that they have given to us. Now there are three values and the first array has 2, 5 and 6. The second array has 1, 2 and 10, right? Now these two are equal, so let us not discuss about them. The only values left are 5, 6 and 110, right? Now you see that you can decrease this value by 4 and you can increase this value by 4, so that this value becomes 1 and it is matching to the 1 here, and this value will become 10 and this will match with the 10 here. So you see, since I have subtracted 4 from it like this and added 4 to it like this, so the total number of operations is 2, because in one operation what you can only subtract or add 2 to the value, right? Now there is also one important thing, that there might be a case when the answer is not possible. In that case you have to return -1. So let us discuss this part only first. In what cases do we have to return -1? So you will observe that whenever we are adding or subtracting anything to a value, we can only subtract -2 and we can only add +2. So if we have an odd value with this before, if we subtract -2 from it, or even if we add +2 to it, it will still be an odd value, right? No matter how many operations you perform, if there was an odd value, it will still be an odd value. Similarly for even, no matter how many operations you perform, it will still be even. So if the count of the number of odd numbers in array A and in array B is different, then the answer would straight away be -1, right? There might be other cases as well when the answer is not possible, but this is the straight away case. Whenever the count of odd numbers in both arrays is different, then in that case the answer will be -1. And we can also only consider one of them, since both of the array contains n integers. So if the count of odd numbers is equal, the count of even numbers would definitely be n minus odd, or count of odd more specifically, right? So this is our very first observation about this question. We have discovered a case where the answer will be -1. Now the second thing that we have to do in this question is, obviously, as I've explained, whenever you change an odd value, it will still remain an odd value, and whenever you will change an even value, it will still remain an even value. So it makes sense to segregate the odd and the even values. So I'll put the even values together and I'll put all the odd values together. So this is 2, 6, 10 and this is 5 and 1, right? Because I cannot change this 6 into this 1. No matter what I do, I cannot do this operation, right? So it makes sense to separate these two values. Now this can be considered as a separate question, but this is an array A, this is an array B, again this is an array A, this is an array B, right? So now in what is the use of segregating these values? The only thing is, now I don't have to worry about whether I can change some value from A into some value from B, right? I know that it is always possible to change this particular 6 into this particular 10, right? How many operations I require, that is a different task, and that we will discover later. But I know for sure that this is the interchangeability now is always possible, right? So the second thing that we'll observe is, so let us write some values here. Let's say I have 1 here and I have 3 here. So now let me take 5 and 7, 9 and 11. Right. So I've taken 3 odd values in both arrays A and B. Right. Let's say these are the odd values that I get or I extract from the arrays A and B. Now you will see whenever they are in sorted order, it is always more reasonable to like make the first value equals to the first value, make the second value equals to the second value, and make the third value equals to the third value. Right. Now if the question was something like this, for example, if 1 was here, 3 was here, and 3 was here, 7 was here, 9 was here, and 11 was here. Now you might argue that we can change this value into this value and then 1 into 7, right, and then 9 into 11. So if you try to do this, let us try doing this. So like in the first case, like let's say we want to change 1 into 3 and 3 into 7. So this will require one operation and this will require, I believe, 2 operations. The number of operations will be 3. Right. Now if I do like in the opposite manner, if I try to change 1 into 7 and 3 into 3, so 3 into 3 will take 0 operations and 1 into 7 will take 3 operations. So you see the total number of operations in both of the cases is 3 only. Why? You might be wondering why is it coming out to the same. So let us write it in a more mathematical form. So what I've done is I've subtracted B0 from A0 and I've subtracted B1 from A1. Right. Like then and like I have added these two values. So this is the first value and this is the second value. Now, even if I interchange these values, that means even if I change the position of these values, so A0 remains as it is, B1 comes at the first position, right? A1 remains as it is and B0 comes at the second position, right? You see that the total sum will always remain the same. So why not just directly like match the individual elements to their corresponding index in the array P, right? This would be our idea. Now, if you try to do this, you will see that if I want to make 1 into 3, that means I'll have to perform one operation, right? Whenever I perform this one operation, that means if this is index I am performing an operation AI is equals to AI plus 2, right? And I'll have to find another index j for which I can perform AJ is equals to A of j minus 2, right? I'll have to perform this operation as well because these operations will only occur in pairs. So let us say I don't want to perform that operation right now, but I'll have to save this information somewhere. So what I do is I use a pending variable. So pending variable will store the pending operations that currently have not been performed, right? So for example, if I added some value, that means I need to subtract some value as well. So let me just store that I've added 2, right? Now whenever for any value, when I have to subtract some value, I'll check whether there is a pending operation or not, right? If this pending operation is positive, then I can drag it to the mean, that is 0, right? Now if I want to perform any operation A of I, that is equals to A of I minus 2, I see that my current pending is 2. What I can do is I can use this particular operation and drag it to 0 so that I don't have to use any more extra operations, right? Because I know that this operation was already performed some time back and this operation can be a pair of that operation, right? So these two can occur in pair. So the way I'll be using the pending variable is, so I'll be using the pending variable to store some information, and that information is if an addition operation has been performed, my pending variable would lie to the right side of 0, right? This is the mean 0. If I have already performed a subtraction operation and there is some and I have to perform an addition operation later on, then it will lie to the left side of 0. So that means I have done a subtraction operation and I have performed an addition operation. So there are numerous ways on how you can implement this particular functionality, but this is just what I did. You can go through your own ideas and perform this operation in your own ways. So this is the whole idea about the problem. Let me just quickly go through it. So the first idea is that an odd value can never be changed to an even value. It can only be changed to an odd value by adding or subtracting 2. And same goes for the even. So if the number of odd values in both A and B differ, that is they are not same, and I can straight away return -1 from there, right? The next thing that I have is it's always reasonable to segregate the odd and even values so that I can perform operations on them separately. Now the third thing is like it again, it is reasonable, I believe, to like just match the corresponding indexes. So if I'm at index 0, I would want to change the a of 0 to b of 0, and then a of 1 to b of 1, and then a of 2 to b of 2. We have discussed why like it results the same value, because by changing the position of p, we are not affecting the total sum, right? That is present here. It is equal in both the cases. Now, whenever I make an operation like a of I is equals to a of I plus 2, I also need to make an operation a of j is equals to a of j minus 2, right? These operations only occur in pairs. So, I might perform that operation later on, but for now, I will have to store that information somewhere, right? So, the way I am storing it is, I am using a pending variable, which is initially 0. Whenever I have performed an addition operation, I just move it to the right? So that it indicates when pending is equals to 2, when pending is equals to 2, that means I have performed one addition operation in the past, and I can use this value to subtract something from my current value. When pending is negative, that means I have performed a subtraction operation in the past, and I can use this value to increase my current value. So this is my idea. Now at the end, I'll also have to check one thing, whether pending is equals to 0 or not. Because if pending is not equal to 0, that means there are still some pending operations. There was some value of a of I for which I changed it, and I have not found a pair a of j yet such that I can balance it. So at the end, if pending is not equal to 0, in that case also the answer will be -1. Otherwise, the answer will obviously be equal to the number of operations that I have counted till. So this would be the whole idea of the problem. Now let us have a look at the code. So what I have done initially is I have created 4 vectors, odd A, which will store the odd numbers of A, odd B, even A, even B. So like these names are pretty self-explanatory. Now I just sort both array A and array B, and I just traverse the array. So if A of I is odd, I just push it into the odd A vector. If otherwise, I push it into the even A vector. Similarly for B, I do the same thing. Now I check if odd A dot size is not equal to odd B dot size, then the answer is -1. Now I create two variables, operations and pending. So both of them are initially initialized to 0, right? So this is my function that I have named do work. So it will do some work for me. And what I do is I just call this function twice. Once for the pair odd A and odd B, so that there are two arrays, so that the first array contains all odd elements of A, and the second array contains the all odd elements of B. Similarly, I call the same function again for all even elements, even A and even B, right? So let us discuss what we do inside this function. So inside this function, what I am just doing is I am traversing through the array.size, and if a of I is less than b of I, that means I need to increment it, right? So you see a of I, I am doing a of I minus b of I, and a of I is less than b of I. So this particular value dx, let me just write it here also, dx will be negative, right? Now there will be some operations. So if dx is initially negative, that means I want to increase the value of a of I, right? So like the way I've implemented might confuse you a little bit, because like everybody has their own way of implementation. So if you want to implement it on your own, you can do that also. The idea will be the exact same, but if you want to see this implementation also, it's totally fine. So in this particular implementation, whenever dx is negative, that means I want to increase the value of a of I, right? This is what I mean. So I have created a variable free that will denote that I have some free operations pending, right? So these operations I can perform for free without adding any more operations to my answer. So that is why I have named it the variable free. So I take the max of pending comma dx. Why am I taking the max value? Because like I want to increase the value of a of I, right? So if I want to increase the value of a of I, there are two values that I have to take care of. One is the dx value. So dx is the amount that I want to increase, right? So this is the number of operations that will take for me to increase the value. Now pending is the value that will denote the number of operations that I already made, right? So in this case, if pending is positive, that means I already made a positive side or an addition operation. So I am taking the max of pending comma dx, assuming that pending could be negative, right? So if I assume pending and dx both are negative, so the max amount of them would denote like the number of operations, free operations I can make. So let me just write it for you as well. So I want to increase the value of a of I, right? This is for sure. I want to increase this particular value. To increase this particular value, I have one option of using the pending value or the pending operations. So if I want to increase the value of a of I, I know that pending would have to be somewhere in the negative side, right? Pending would have to be somewhere in the negative side, because when I use the subtraction operation, I decremented the value of pending. So there will be two values, pending and dx, right? So dx is the number of operations I want to change. So if like I will take the maximum of them. Pending is somewhere here, dx is somewhere here, right? So this is the actual number of operations I want to make, and this is the operations I can make with the pending variable, right? So I have to take the maximum of them, whichever of them is closer to 0. So that is why I take the maximum of them. But there might be a case when pending was actually positive, right? So I don't need to take the positive value, I have to stick to 0 as well. So the 0 is the maximum value that I can take. So that is why in the next slide I am just doing free is equals to minimum of 0 comma free, right? So this is what I'm doing. So dx will never be positive, pending variable can be positive. For to counter that, I am doing minimum of 0 comma free, right? Now I subtract these free operations from pending. Again I subtract these free operations from the value of dx. So if dx is still remaining, that is after using the pending variable or after using the free operations, I still have to make some changes, then I'll add it to my answer. Since dx is negative, I'm just subtracting it from the value of operations so that it gets added, so the absolute value is added to it, right? So like an easier way to write this is like this. You can also write it like this, like both of them are correct. Now I also subtract the pending, the value of dx from pending, right? So this is very simple. Again, it is happening the same thing. It will actually get added to it. So you see, as I've told you, whenever I do an addition operation, I just move pending to the right. So this will also do the same thing. I can also write it as pending plus absolute of dx. So both of these are equivalent. Now we will consider the same case when a of I is greater than b of I. Now in this particular case, a of I is greater than b of I. So the value of dx will be positive. So the value of dx will be positive. Now again, if the value of dx is positive, that is I want to decrease the value of a of I. That means the pending value should be positive. Why? Because pending value will be positive when I made the addition operation. But I want to decrease, so I want the pending value to be positive, right? But there might also be a case when pending value is actually negative. So after computing this value, I'm actually taking free is equals to max of 0 comma free, right? So again, in this case, both will be so the value of dx will be positive and the value of pending can be positive and negative as well. So I'm taking the minimum of it. In the next line, I'm just setting free is equals to max of 0 comma free. Now, if I can perform some free operations, I'll subtract it from pending, I subtract it from dx. Now, since dx is positive, I'm directly adding it to the operations and I'm directly subtracting it from the pending operations. Why am I subtracting it from the pending operations? Because just now I performed a subtraction operation and the value of dx is positive. So I want to subtract it from the pending, right? So that pending moves more towards the 0 or more towards the negative, whatever you can say. Now since these once I've explained this particular function do work, it will work the same for of the odd A odd B and same for the even A even B. After both of these operations are performed, I just check whether pending is equal to 0 or not. If pending is equal to 0, that means I have no operations pending now and I can just safely return my answer. Otherwise, the answer will never be possible and it will be -1. So this was the solution for today's problem of the day, unequal arrays. So I know that this was a bit of an implementation problem, and it is possible that my implementation is more like you might find it difficult, and there might exist some simpler implementations as well. So it's totally up to you how the way you implement it. But I believe that this was a little bit of an implementation problem. Other than that, the rest of the problem was fairly simple. So I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to this channel. It's all free of cost, and you can always unsubscribe later if you don't find the videos interesting. So till the next video drops, keep coding, stay safe, bye bye.